Okay, so again, continuing where we left off, we were doing the conclusion section and we're talking about experiment 2. And as I mentioned, the conclusion is that when you decompose a hydrate, it tends to lose water, and so the mass is less than what you started out with because of the loss of water in the form of water vapor. But this particular hydrate also lost carbon dioxide. So you started out with a single compound and you formed several compounds, 3 products. So 1 reactant and 3 products. The copper 2 oxide, the 2 moles of water, and the 1 mole of carbon dioxide. So a real world example of decomposition is just hydrogen peroxide breaking down into water and oxygen. So that 3% peroxide bottle sitting in your medicine cabinet over time, especially if it's sitting around for more than 3 or 4 years, is going to be just plain water as the oxygen has completely vaporized out. So in experiment 3, the zinc replaced hydrogen. All right, so it took the place of hydrogen, and that's how you saw that the bubbles of hydrogen were coming out, showing that the zinc had taken its place, right? And then you saw the metal disappearing, or rather being eaten up by the acid. A real world example is removing the tarnishing. For example, tarnish is again a synthesis, because silver is combining with sulfur from the air to form silver sulfide. Now, how to get back the silver? What you do is you rub the tarnish with some foil, aluminum foil, which is aluminum metal, and the aluminum is going to take the place of silver. It's going to push the silver out, and it's going to combine with the sulfur, and so your pristine silver is going to reappear again as the tarnish disappears. So in experiment 4, most times when you mix 2 solutions, you might or might not see, but a lot of the times you do see a solid coming out of solutions, or you see bubbles forming, which indicates the formation of gas. For example, when you take sodium bicarbonate and add vinegar to it, you see bubbles of carbon dioxide forming. So this bubbles is an indicator of a reaction happening between the sodium bicarbonate and the vinegar. All right, this is an example of double displacement reaction that you see in everyday life, especially if you are cooking in the kitchen, etc. So most double displacements are involving the cation of that first reactant swapping places with the cation of the second reactant. As I mentioned, exchange of dance partners is an easy way to look at it. So the nickel 2 hydroxide precipitate formation indicates that reaction has occurred, that double displacement has occurred. If you mix 2 solutions and you visibly don't see any kind of bubbles forming or a precipitate, a cloudiness developing, that means basically there's no reaction happening. Okay, so some real world examples of double displacement is taking an antacid, which is a base, and taking it to neutralize excess acid, especially when you have indigestion, etc. Okay, so and then, as I mentioned, sodium bicarbonate and vinegar is another double displacement reaction from everyday life. So some more real-world applications of chemical reactions. Respiration. Respiration is basically glucose reacting with oxygen, forming carbon dioxide and water. Now, photosynthesis is the reverse of respiration. Here, you're making food or glucose, and so what's happening? Carbon dioxide and is taken up by plants and combined with water and then converted into glucose. Okay, basically, um, the respiration is a kind of breakdown or an oxidation, and then here in photosynthesis, that's a synthesis reaction because carbon dioxide and water are getting transformed into glucose. Digestion also are types of decomposition reactions because you're breaking down food, complex food, proteins, carbohydrates, fats into smaller molecules. So that's decomposition reactions that are happening. Decay of animal or plant material are also types of decomposition reaction. The table salt that you use every day, sodium chloride, is made by combining sodium metal with chlorine gas. So that's a synthesis reaction. The biochemical reactions happening in your body are enzymatic reactions, and these are all of them. There can be combinations of decomposition, single and double replacement, right? Cooking is a chemical reaction as well. So what are some of the applications for nursing? Understanding acid-base chemistry, to understand homeostasis or the balance in the body, right? We talked about acidosis and alkalosis previously. Acidosis is when the blood pH drops. Alkalosis is when the blood pH goes up. Both are harmful conditions and in extreme cases can lead to death. Understanding how a particular medicine will interact with cross-react with other medications that a patient might be taking. So this involves having a good solid knowledge of chemical reactions in general. Suppose you have to administer IV to a patient, and the patient has some previous disease and is taking medications that might interfere with those chemicals in the IV solution. Again, this would require a good knowledge of how chemical reactions work. So these are some of the ways that chemical reactions come into play in everyday life. And that, I believe, is the end of this video.